In this tutorial, we will see what is a lift chart in the context of binary classification using logistic regression, how to create a lift chart in RapidMiner, and how to interpret its output. Now, let me open up RapidMiner in just a second here. Okay, so our starting point is the process model that we had created for the previous 3 tutorials, where we are trying to classify individuals with coronary heart disease. So you have a data set that has 2 types of observations, 2 types of individuals, those who have coronary heart disease and those who don't. And we built a model to try and classify those individuals. And in the last tutorial that we had, we discussed the performance metrics that are generated based on the confusion matrix that is generated from the validation data. So this is our starting point. So let me just run this process again. And you may recall that we went through a discussion of this confusion matrix, which I said was the basis for all performance metrics that are generated in for binary classification. Now we are going to create a lift chart from this. So let me first show you what a lift chart looks like in general and in RapidMiner, and then we'll get into the mechanics of creating it. So I have created another process, and so keep this process in mind. There's all these different pieces to the logistic regression, and then this last bit where we actually compute the performance. Okay, so here is the process that will generate the lift chart. So first thing to remember is the operator that you use in RapidMiner to create a lift chart is called create lift chart. Okay, so next let me run this process and you'll get to see what a lift chart looks like. So here is, I run the output, and this is what a lift chart looks like. Of course, we will dive into this in more detail in just a little bit, but visually this is what a lift chart looks like. Now, the reason I'm not discussing it right away is that I want to discuss a little bit about the mechanics of developing this particular process model. You can see that everything about the process model is the same except this last step, where instead of having the performance operator, we have this create lift chart operator. Now, in order to explain the content of a lift chart and how it works, how it is used, it would be helpful if I could also have that performance operator here. Unfortunately, with a little bit of a snag, not a snag, but something we have to do, because you may remember that at least for all the RapidMiner models that we have developed so far, you can't take the output of one port and then connect it to 2 different input ports. So you can look anywhere in the model, one output port always connects to one input port of a following operator. However, if I want to put in the performance operator here, so let's see, here's the performance. Let me pick up the binary performance operator here, the binomial classification. If I were to bring the binomial performance operator that you saw in the previous process, then it also needs the same input. It needs these examples as input over here. So I cannot connect this output to these 2 ports at the same time. So I have to do something a little different. There is a convenient operator in RapidMiner called multiply, which basically duplicates output ports. Okay, and then you can feed it to, well, more than one. You can feed it to not just duplicate but triplicate if you want. So you can take one output and feed it into multiple operators following it. Okay, so that's what we're going to, and the reason we are doing it is so that I can explain how a lift chart works and how it's to be interpreted. Then I need to see the performance operator, the output of the performance operator as well. So just bear with me. I will just move things around a little bit just to show you how I would use the multiply operator. Okay, so for now I just disconnect this. All right, so This is performance. So I have to bring in this operator called multiply. So here's your multiply operator. And what I do is I take the examples generated by apply threshold. So apply threshold in the logistic regression, it takes the probabilities, applies a threshold, and decides which category the individual should be assigned to. And all that multiply does is it creates copies of this output. So one copy, it starts out with one copy. So I connect one copy to performance. Okay, and do you see, as soon as I do that, a second copy is generated in the multiply output port. Okay, so let me connect the performance output to the results port. I'll take the second copy of the labels and I'll connect it to the create lift chart, and I will take the lift output and connect it to, lift is already connected. Oh, good. So then I have the performance output as well as the results. And if I want to see the model, I can see the model as well. So hopefully we have created all that little congested. Let me see if I can create a little space here and move multiply back. Move these a little bit forward perhaps. Oh, that's more congested. Okay, let's see if we got everything here. All right, so essentially what I've done is I've combined those two models where I can see both the performance as well as the lift chart. So let me see if this runs correctly now. I'll make sure I run it. Oh, good. So it's the combined process has run properly. So notice that I can see the lift chart now, and I can also see the performance vector. So I've just done this so that make it easier for me to explain what's going on. So this confusion matrix I'm not going to cover again. We've looked at this at the prior two tutorials. So let's look at the, let me get back to the design. And yes, I want to see the examples. I knew I had missed something here. Okay, connect the examples. So when I connect the examples to the output, to the results port, basically I will be able to see both the actual classes and the predicted classes of the observations. Okay, so let me run again this process. So here's the example set. So I wanted to see the actual versus the predicted. So this will just help me explain what the lift chart does. Okay, so first let me get back to the model. Once we have trained this model, as you can see, we have trained it and we have split the data set, and we have got a validation data set to which we have applied a threshold. By the way, the threshold is set at the default 0.5. You can always change that around. And then the validated model, we have run it through this performance operator to calculate various things like sensitivity and so forth. And then we generated a lift chart from it. Okay. So first discussion we will have is, once you have this trained model, how do you use it to do a good job of identifying individuals? Okay, doing better than just randomly trying to select. Okay, so here are the results. So we have the actual classes and the predicted classes. And the way you try to use the model to skim the cream, so to speak, of who you should target. So if you think of this as a marketing campaign, and if you think of the individuals with coronary heart disease as the people who will respond to a promotion that you're putting out, then what you want to do is use the model to send these offers out to a limited number of people, but get a higher response rate. So one alternative you have is just mass mail these offers out to a whole bunch of people, and you will get a certain response rate. Okay. On the other hand, if you use your model, you hope to be able to limit the number of individuals that you send, thereby reducing your mailing costs or the cost of sending the offers out, and you hope that a larger proportion of them respond to your offers. Okay, so these lift charts are used fairly frequently in marketing settings, but here is how you would use the lift chart. So what the logistic regression model does is that it takes the independent variables, and from that it generates the probability of this individual or this observation being in a particular class, in this case a CHT. Okay, and all that the threshold, in our case the threshold is 0.5, all that the threshold does is it takes this continuous probability value and uses that to put an individual in a class. So if the probability is greater than the threshold, then this individual is put in category 1, that is CHT. If it's less, then it's put in the other category. Okay, so then how do I use this trained model to do a better job of targeting who I sent my marketing offers out to? Or in this case, how do I do a better job of identifying who my CHT patients are, rather than just looking at this data set and trying to and doing that randomly? Okay, so this second column over here, which says confidence 1, these numbers tell you the probabilities of this individual. So it's patient number 1 or individual number 1, the likelihood of this individual being in category 1, being CHT, is 0.093. That's what's been calculated by the model. Similarly, the likelihood of individual 11 being a CHT case is 0.17. So what do? I sort there are about 1,000, I think they're about, you can see here, there are about 1,100 individuals in this validation data set. So what do? I sort these in descending order by probability. Okay, so, and you can see the observation numbers have gotten scrambled here, as you would expect them to. Okay, so what this means is patient number or individual number 989 has a 0.94 probability of being a CHT patient. So once you have the individual sorted by probability of being in CHT, our threshold was 0.5. You can see, so if you scroll down, as soon as the probability drops below 0.5 here, you can see the algorithm or the model classifies the individual as being in the other category. Okay, so the second column is the predicted category. The first column is the actual category of this individual. And sometimes the model is right, sometimes the model is wrong. So you can see in the first case, patient or individual 946, the model prediction was correct. It correctly predicted that this individual is a CHT case. Patient number 81, the model misclassified. Patient 15, the model classified properly. Okay, so remember these rankings. So this is how you so instead of sending out your marketing offer to 1,000 people at random, and maybe 10% of those will respond, what you do is you sort these individuals by the probability of their being in category 1. Okay, and then from that try to decide, instead of sending it out to 1,000 people, maybe I just need to target the top 25, or maybe I just need to target the top 50 in order to get most of the people who would have responded from that random mailing. Okay, so you're trying to do a more targeted mailing of your offers in a marketing setting. So just remember this sorted structure after the model has been calibrated. So if you keep that in mind, it will be helpful, useful in understanding what the lift chart looks like, with the different components of the lift chart, and how to interpret what's there in the lift chart. Okay, so now let's look at the lift chart. So this is what it looks like. First, let me just show you, I haven't shown this to you yet. All I've said is you use now go to design. All I've said is you use the create lift chart operator to generate the lift chart, but I haven't, shown you its parameters. So when you create the lift chart, first of all, you have to tell RapidMiner what is the category for which you're generating the lift chart. In our case, category 1 corresponds to the individual having CHD. So that's the target class for which I'm generating the lift chart and for which we have computed, which will be computing lift. And we use the absolute values of the probabilities for binning, and we are setting a bin size of 100. And why bin size of 100? It makes it easier to calculate percentages. And in our case, we have about 1100 observations, so that will give us about 11 bins, but 100 is a nice number to compute percentages, so that's why those bin sizes are 100. Okay, so those are the parameters that were set for the lift chart. So when you run it, it generates these predictions from the model, but now our interest is in examining the lift chart. Okay, so here's what the lift chart looks like. And that's why you see these denominators is 100 in each of the bars. Why? Each bar represents a bucket of 100. So remember how the observations in this validation data set was sorted by their probability of being in category CHD or being in category 1. So when it says 40 over 100, what this bar is telling you is after you have sorted the observation, and the only way you can sort the observation is by using the results of the model. That's why we are trying to examine, does the model do any better than random mailing out or randomly trying to identify who the CHD cases are. So what this first bar is telling you is that if you pick the 100 individuals, if you pick 100 individuals identified through this sorting that you got from the model, 40 of them will turn out to be actually having CHDs. So that's pretty good, isn't it? So the model allowed you to target 100 people and 40 of those have CHDs. Think of what would have happened if you had tried to randomly identify who the CHD cases are, or if you translate to a marketing setting, if you had send your marketing offers out to 100 persons at random, then 40 of them are not going to respond. Your model has allowed you to target the audience much better, so that the response rate is increased. Okay. Now the second bar, 28 over 100, what it is saying is that if you look at the second 100 individuals in that sorted list, 28 of them will actually turn out to have been in the CHD category. Okay, so each bucket is of size 100. So first 100, second 100, third 100, and the numerator tells you in each of those buckets how many individuals actually turned out to be CHDs. Okay. Now, if you look at the validation data set, I think there were about 167 individuals actually with CHDs. So if you add these numerators, 40 plus 28 plus 25 plus 13, 10, 17, 11, 7, 4, 9, and 3, you should get about 167. So it tells you how the model was able to identify each of those in which order after the sorting of the individuals. Okay, so similarly for the third bucket, if you go to the third 100, then there were 25 individuals who were identified to be CHDs. So just to show you how this calculation is done, the 100 is kind of hard to see in that list. What I'm going to do is I'm going to get back to design, and just to show you how those numerator and denominator are determined, I'm going to go back to lift chart, and instead of size 100 for the bin size, I'm just going to make it 10. Now that'll create a lot of thin bars, but it'll make it easier for me to explain how the numerator and denominator were obtained. So I'll run this process again. Now if you look at the lift chart, do you see these very thin bars? Because each bar now represents 10. Okay, so look at the first bar. It says 10, 8 out of 10. Okay, so let me show you where that 8 out of 10 comes from. So here is the sorted. Oh, it's not sorted. Let me sort it. Okay, so remember, so we sorted the individuals based on their probability of being in CHD. That's what the model allows us to do now, once it has computed these probabilities. So I'm going to pick the first 10 individuals from this sorted list. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the first 10 individuals in the sorted list. Now, if you go through this go through these 10 individuals, do you see that 8 of them, 1, 2, 3, 4, 5, 6, 7, 8. 8 out of those 10 actually turned out to be CHT cases. That's where you got that 8 over 10 in that first bar. Okay. Similarly, if we go to the second 10, sorry, in the sorted list, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the next 10. Out of that, 1, 2, 3, 4. 4 individuals were actually CHT cases. So if we go back to the lift chart, there you have your 4 over 10. The 10 is overwritten, there's a little scribbling over there. So that's how the numerator and the denominators were determined. Okay, so there are too many bars here to give us an eyesore. So let me get back to design and increase the bucket size back to 100. But at least I hope you understood where the numerator and denominator comes from for each of those bins. So let me run this process again. And here's a lift chart. So I explained to you what each of these numbers mean. And informally, you can see what has happened is that as a result of this sorting and this probability generation by the model, you have been able to target your audience much better. So you're doing more with less, basically. If this was a marketing setting, you'd be getting a higher response rate. You'd be able to target your audience much better. So what does this black line represent? So this is the cumulative percentage. So and on the right hand side, so the baseline that if you are identifying CHT patients at random, or if this was a marketing setting, if you're sending out your marketing offers to customers at random, without trying to target them, then what kind of a performance you would get. So think of the x-axis. The first bar is the first 100 individuals in the sorted list. The second bar is the second 100 individuals. The third bar is the third 100 individuals. So these are sort of since we have about roughly 1,000 individuals, actually 1,100. So you have this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 buckets. We get roughly 1,100 individuals that we have. Now, if you did things at random, look at the y-axis over here. It says % of 1. That means category 1 is our CHTs. So the y-axis over here is what percentage of the CHTs have you identified. So clearly, as you're going from left to right on the x-axis, you are targeting more and more individuals. So it would stand to reason that if you're doing things randomly, if you targeted 50% of the total population, then you should get 50% of the respondents. Okay, so the baseline lift, as it were, that you can think of is a 45-degree line from here all the way up to here. Now, RapidBinder doesn't draw that line for us. I wish it had, but imagine that's your baseline. So if you did things randomly, if you did your classification randomly, then the more you target in the population, the higher the percentage of the target you would identify. So, but it would be a straight line. So if you targeted 50% of the population, that's the x-axis, then you would identify 50% of category 1. So your baseline is this 45-degree line here that I just drew with my cursor. Just imagine that line is there. What this lift curve is telling you is how much better than random you're doing. So ideally what you would like to see is a lift curve that is very steep, okay, and then flattens out. Which essentially, informally, what that means is by targeting a very small percentage of the population, you're somewhere here, okay, you can get a much higher proportion of the target category returned back to you, okay. So you're doing more with less. So you would like to see a lift curve that's steeply increasing and then flattened out over here. That's not the case here. It's kind of a little bit flattish, but that's what these numbers mean. So let me just show you where this, so this first data point here in the cumulative lift curve is at about 25%. Okay, so if you go across to the y-axis on the right, it is about little less than 25%. So where did that come from? We have identified 40 of the CHT cases, and I told you there were roughly 167 CHT cases in this data set. So 40 divided by 167 is about 25%. That's where the 25 came from. So next value you see over here is around 40%. So where did that 40 come from? So when you targeted another 100 individuals, your model allowed you to identify 28 more CHT cases. So cumulative, how many have you identified? 40 plus 28, that's 68. 68 divided by 167 is about 40%. So that's how this cumulative keeps creeping up, sometimes a little bit less, sometimes a little bit more. Ultimately, when you have send it out to this, or your marketing offer out to the entire population, which is here, you have obtained the entire group of category 1 from that population. Okay, so this cumulative has to end at 100% because you have covered 100% of the population. So this is what a lift chart looks like in RapidMiner. There are different ways to present it, but that's basically the idea behind the lift chart. You're trying to do more with less by targeting your audience better using the results of the logistic regression model. And the basic step there, remember, is to use the probabilities generated by the logistic regression model to sort your data and use that sorted list for targeting. Okay, so this is what a lift chart is and how you run it, how you implement it in RapidMiner, and you interpret its results. So let me get back a little bit to the construction. Remember, if you don't need to see the performance operator while you're creating a lift chart, there's no reason to use the multiply operator. The only reason I use the multiply operator is so that I could explain the lift chart, the guts of the lift chart to you by referring back to the output from the performance. Okay, so that's why I had it. Otherwise, you don't really need the multiply operator. So I leave that to your discretion. Okay, thank you. That's all there is. All I had to say for this particular tutorial.